back in and make sure that you each have one of these so you know how to follow along with what Taylor's going to tell you. So you're gonna talk about how to create effective scientific research posters and how to use one particular program to help you make really good images. With that,
okay.
Dr. Starks.
Pleasure to be here. So I've given this talk a bunch of times in the past. I show the software and I show how great it is, but it's a little bit tricky to learn how to use. So we decided to change our format this time around. And I'm actually going to talk a little bit about how to make posters. And then I'm actually going to show you how to use this software. And I'm actually screen recording this right now. So even if it's unclear in the demo, hopefully we'll make this available on YouTube. And if you want to go back and use this, it'll be available. And I'll tell you why I think it's worth learning as we go. So to start with, my name is Taylor Sparks. I'm in the Material Science and Engineering department. That's the engineering discipline that nobody's ever heard of, but is, I think, involved with everything because every engineering discipline has to do with materials. And even if you're not studying engineering, you're still dealing with materials, probably. Probably everyone in this room. So today, what are we going to talk about? I'll discuss, first off, what are the qualities, at least in my opinion, and this is totally just my opinion here, of a nice figure and of a nice layout for a research poster, which is important for you guys because in about a month's time, roughly, is it? You're going to be putting together your own posters on the research you're doing right now. I'll then pivot for the rest of the time. I'm going to talk about how to make effective figures and posters, so talk about some of the tools you can use. And if there's time and or interest at the end, we can even talk about how do you make nice slides and how do you present nicely, right? So if you take nothing away from this, right? If you're going to write down just one thing from this entire talk today, write down tiny.cc/Dumont. That's with a U. D-O-U-M-O-N-T. Jean-Luc Dumont is sort of, at least in my opinion, the very, very best at communicating science to other scientists, to non-scientists. He's just the best. He has terrific slides, terrific figures. Everything he does is wonderful. And I promise this will be worth your while. That link will redirect you to about a 1 hour long YouTube video, which, over your next lunch break, I really strongly suggest you watching it because everything I'm going to teach you comes from that. He also has a book. And ironically, the guy who's a master communicator and just the best at communicating effectively came up with a really rotten name for a book. Trees, Maps, and Theorems is the name of the book. I have no idea how that ties in, but it's about effective communication. So ironically, that's the one thing he doesn't do well. So let's start by talking about, first off, what is graphical excellence, right? What is a nice figure? Well, I'm going to put forward the argument that graphical excellence is well-designed, interesting data, right? Or in other words, an effective figure can take something that's complex and difficult to understand and portray it in a way that's simple, clear, precise, efficient, right? And this is the example I normally start with. This came from research I was doing as a postdoc. What we were trying to describe was a really nuanced, hard to describe finding. For example, we had measured 4 different types of materials properties. I won't describe them, but these 4 different y-axes, those were 4 different things that we'd measured, right? They were all measured as a function of temperature. And what we were really trying to tell the people who read this paper is look, there's 2 magnetic transitions that were known, this one and this one, before we did this work. Here we're providing a lot of evidence to say we think there's a third, right? So by plotting all these different, albeit very different types of data in a very specific way with guides for the eye, we can make the case for it, hey, it looks like something is happening at this temperature where nothing had been known there before, right? So I think graphical excellence takes a complicated concept like that and makes it as simple as possible for the viewers or the readers to digest that. So how do you go about making graphical excellence? What else is involved in it? I'd say the best thing you can do is find somebody who makes very nice figures and copy them, right? Just straight rip them off. You're paying them a compliment, right? I rip off my postdoc advisor's way of doing figures. I now have my graduate students and my undergraduates doing the same thing, right? So that said, let's go to my postdoc advisor's group, Ram Seshadri, and see how he does his figures. So for a presentation he put together, nice figures. First off, I like this that he puts together and he says, as research, you're going to spend a lot of time, money, effort, spending other people's money, for example, to gather your data and to generate it. You owe it to yourself, to your readers and the people who fund it to make it as easily interpreted as possible, right? You should try and make this as easy as possible because a lot of work has gone into it, right? So don't just hodgepodge it all together. Actually take the time to think about your reader and tell them a story that's going to be meaningful for them. Now this guy's got opinions on everything from font to color palettes, right? Take it for what you will. There are some useful things he describes here, right? In the world of fonts, there's sort of two categories. There's serif and sans serif. What does sans serif mean? Anybody? Sans always means without, and then feet, yeah, that's the serif, right? So if you look at the letters, this is like a Times New Roman sort of thing. This is Minion Pro, but Times is like this, right? If you look at the bottom of the letters, this projector's not amazing, but there's little feet there, right? Meanwhile, you have, so that's a serif font. Then you have sans serif, meaning no feet. These won't have it, so this is something like a Helvetica or a Calibri, right? So when do you use one? Which one, right? It's just a matter of total taste, right? To some degree. But he does make a good point that these, because they have the little feet, they make it easier to read in paragraphs. So if you do anticipate having a block of text, like in a research article, it's very appropriate to use a serif font. If you're going to be presenting something like in a PowerPoint, it's actually not necessary because you're going to have a short blurb of text and a sans serif is a little bit clearer to read. Right? There's less going on. Obviously, there's some fonts you want to have just ignored outright. And I say this to not use Comic Sans, but I see it all the time. Or there's this one student I had who put together a PowerPoint presentation for a company that we were working with. I didn't get a chance to look it over ahead of time. He pulls it up and he's got like this old Western font with like bullet holes shot through the letters. He's like, ah! It's childish, infantile, right? All these words kind of describe that. So I would suggest avoiding it, right? All right, let's talk about plots, though. This is where he really has some good thoughts. Here's what he suggests is a very nice plot. Here you can see what stands out as a good plot here. Everything should be visible, I hope, from the back of the room. Are these numbers visible from the back of the room? Hopefully. I have terrible eyesight, so maybe half the room for me. You've got two different data sets that he's showing. You know it's two different data sets because the legend says very clearly that you're looking at two different data sets. And more importantly, you've got two different colors, blue and orange, which will print in different colors in grayscale, right? They'll actually be, you'll see the difference if you print that on a grayscale. Like if you're a cheap graduate student, you only have a black and white printer, you'll still see the difference between those. But just in case, he's made one with a broken line and one with a solid line, right? So he's tried to make it as easy as possible for the viewer to interpret the two different sets of data here, right? He's also gone with a square figure with nice big spaces between the ticks, right? With really big labels, with constant text size all the way through. All this is sort of hallmarks of what he considers a good figure, and I tend to agree with him. We'll show you some examples why. One reason why we like square plots, you might see square plots, that's silly to care about that. There's a reason why we like it. A square plot will shrink gracefully. What do we mean by that? When you do your research article, if you guys, hopefully your PhD advisor or your mentor that you're working with has been showing you articles, oftentimes they're in a 2-column format. That's sort of the standard, right? And it's rare that you get to put a full figure on a page. Very rare, right? You have to convince the editor that it's worth their money to put that huge figure on the page. More often than not, they're going to take your data and they're going to shrink it down to so it fits within a 2-column format. If you beg, they might make it fit stretched across the banner. So because of that, by the time this thing shrinks, it's taking up about 3 inches, right? If you made it a square plot, it's much more easy to interpret the data that's in there. We'll show you a counterexample in just a moment. He suggests to not use some colors. Now, when you're presenting, it's especially bad. When I look at my computer screen, that green and yellow are almost invisible. On some TVs, it might be the case. Here, projected, they show okay. But if you're going to pick a really obnoxious color, it might really stand out. Maybe you want it to. Maybe you've got one data set or one data point you really want to stand out. It's okay to use them for those instances, but most of the time, be aware that colors, you want them to just be easily read and not distracting. So here is an example of a bad plot. We've seen some data plotted down on a good plot. We're taking the exact same data. Believe it or not, this is the exact same data, but on a bad plot. This is the standard output on a piece of software called Maple. Anybody use Maple? It's a math software. Some people might use it. This is, if you don't mess with the settings and tell it to do something different, this is what it spits out. So what do we like and dislike about this? One thing I dislike is these font sizes are very, very small in the numbers there. I doubt you can read those in the back of the room. Maybe you can, you got better eyesight than I do, but it's much harder. This is gigantic. These are small, the legend size is small there. The stroke, meaning the thickness on these lines, is really, really thin. And they've done red and green, which even if it's printed in color, a colorblind person won't be able to tell these two apart. There's no broken versus solid line here. So you've got, here's one tick thickness here, and you've got, that's like 3 major tick thicknesses on the y-axis. It's just inconsistent, right? A lot of inconsistencies. And this is when it's 5 inches wide, right? By the time you shrink this down to a 2-column format, here's the exact same data plotted in 2 different ways. Again, that same plot that just the maple spat out is very, very difficult to interpret, right? Very hard to read in those numbers. Whereas the same exact data with a little bit of care plotted this way is still very easy to interpret, right? Now, many of the data that you're going to work with is going to have insets, meaning maybe some small detail of your plot you want to make larger to draw attention to some aspect, right? In the data that I showed you at the very beginning, we showed 4 different types of data, and that little nuanced thing happening at a certain temperature, that's an example of what you might want to draw, their eye to, saying, hey, there's something interesting happening right here. So insets are a great tool to do that, but unfortunately, there's right ways and wrong ways to do insets, and the vast majority of people do it the wrong way. What's the wrong way? You make 2 figures in Excel or PowerPoint, wherever you make these things, then they shrink one down and they put it on top of the other one, right? And in doing so, all of this text by the figure is completely gone, right? However, if you take a little bit of care and you plot it on top of it, and you make sure that your font size is uniform all the way through, you can actually see what the tick marks are so you can interpret the data, it's a much, much better way to go. So again, we'll show you the 2 side by side. First off, instead of doing an inset, this is what our group mostly does, consider a multi-panel plot. This is something that Excel can't do, and this is why we're going to show you how to use QtGrace today. A multi-panel plot's way better, right? You can plot something on the same x-axis or different x-axis. If you remember on the PowerPoint, all of our x-axis was temperature for all 4 of them, but we could have lots of different y-axes to draw your eye to that temperature without something happening. Here they've got a linear versus a logarithmic axis, right? That was what they're trying to point out here. But again, what common folks will do, and you see this all the time in literature, you'll find an inset where they simply took a second figure, they shrunk it down, and now none of this is legible at all. You can't tell that they're supposed to be doing linear versus logarithmic. It's completely gone, right? When I review papers, if I ever see an inset like this, I reject it immediately. I say, send it back when you've got appropriate legible figures, right? Because you can't read this at all. The stroke of these lines is also shrunk. They become very, very difficult to see as well. And that's on a expanded format. When you shrink that to a 2-column format, it gets even worse, right? This data is now impossible to read. Like, why bother? Why bother doing all that work, plotting it in the first place if no one's going to be able to interpret this data, right? Okay, plots from instruments. How many of you guys use a spectrometer or something where the data, the instrument just spits it out? A diffractometer or something? Maybe half of you guys, or I don't know. It's pretty common. And oftentimes these machines, because your advisor's cheap and doesn't want to buy a new instrument, he or she says, oh, just take the data, screen capture it and use that. That's terrible, because the screen capture of these things can be really wrong. Here's the spectroscopy data. In spectroscopy, what you want to know is intensity, which is arbitrary units, meaning you don't care what the intensity values are. You just care about the relative intensity. So you should tell them that. Over here in the y-axis, this doesn't say that. You just see numbers. You're left to wonder, does that have some unit I should care about? So you should write arbitrary units, right? So people will know, oh, I don't care about that. And then over here, you've got wave numbers. Strangely, put it clear over here. Absorbance divided by wave number, that cm should be centimeters raised to the -1 power, then just put -1 next to it. Like, again, this is an uncommon example of how bad machine output is, right? If you just look at them. There's no tick marks, so if you're trying to tell where this peaks out, which is usually what you care about in these things anyways, how do you know where that peak is at right here? You're like, well, counting backwards from 1500 to 1000, it's 1400, right? It's not a very useful plot, right? So later on today, we're going to show you how to take data from this, even if you don't have the XY data yourself. Maybe it's in the literature, right? Somebody else reported this with their terrible machine data. We're going to teach you how to extract the XY, to turn it into an Excel file where you can plot it yourself, right? And there's actually pretty simple tools for doing that. It gets worse when you shrink it. All right, what about microscopy? Who's going to take a microscope image for some of the research, or an optical image for that matter? Anybody during their research this summer? Again, maybe a third or so of you guys. It's pretty common. And this is what they usually look like. In a general research article, if you pull it up and look something like this, and you might say, who cares? It's fine, right? But can it be better? Can it be clearer? Yeah, you betcha. First off, the machine, by default, is going to spit out all of this stuff. Things like your accelerating voltage, your spot size, if this is a scanning electron microscope. it shows you the one thing you do care about, which is the size indicator, right? The scale bar. But it's really, really hard to see in this. I doubt you can read that number there, maybe, right? It's very, very difficult to read. So consider doing the following. Take that exact figure, just like it was, crop a square out of it, because you like square figures, right? Draw your own scale bar, make sure that it's the actual size, you take some care with this, and then draw your own indicator for what that scale bar is, and it's much easier to interpret this data, right? If it's critical that they know that it was taken at 20 kiloelectron volts or whatever the accelerated voltage was, put that in the methods section of the paper, just write it down, but you don't need it confusing the image here. He's got a few notes about using PowerPoint. I'll come back to this later when we talk about actually making posters. I'll come back to that. Okay, so then he's got a bunch of great examples of good figures, right? So again, this is sort of like the data I showed you in the beginning. You've got one thing in common between these three measurements, and that's temperature. They were taken at different temperatures. Here they've got a heat map, and at the far end of the heat map, they were nice and they actually showed us what a 2D plot of that single temperature would be. And over here they've done the same thing at this single temperature. What does that plot look like? Which makes it easier to interpret the heat map data. Nice use of colors. Everything's large enough. It's the same font throughout. Just a nicely prepared figure, right? Shrink's okay. You can still read it even when it's shrunk to a 2-column format. Another example of a nicely used heat map. He suggests to avoid using dark backgrounds. This comes more into play with the PowerPoints, that even if you have really nice data, a dark background can make it look poor. And the example he gives, which is kind of clever, is the discovery of superconductivity, right? The discovery of superconductivity is a very big deal, and even it looks bad on a dark background, right? So I tend to agree with him. I think, PowerPoint's got a bunch of templates for you to look at. I suggest just a plain white template. Maybe you'll see what I continue to use, what I think is a good figure, but you're welcome to do whatever you want. I think this is a good template, right? Here they have another one with SM images. This one's clever. They've taken it overall, it's a square image, but they've got parts A, B, and C. Part A is the most zoomed out, right? They zoom in, they're showing you the scale bar, changing the color to make it just the most legible possible, right? And then they even show the selected area fraction pattern, which is basically saying, if you were to zoom in on one of those and determine the crystal structure, this gives you that information, right? So it's a nice way to package a lot of information into one plot. It takes a little bit of effort to do these, but it's really not that hard. This is like throw it in paint and put a crop box on it sort of stuff. This isn't that challenging to do, and it makes a much nicer, much more professional looking figure. Anybody working with molecules or crystal structures or crystals or anything? A few people. Learn how to use the software that's out there to draw these things, right? Instead of in PowerPoint trying to draw like little circles and little sticks between them, first off, it's not easier. That's a lot harder. And it's not that hard to learn how to use this stuff. One piece of software that's great that I use is Vesta. It's totally free, completely free to use. All these figures were generated with it. Pretty simple to do. And it makes things that look much more professional. And moreover, maybe you don't know how to use Vesta and you're like, I just won't add the figure. It's hard for people to understand that you're talking about, the number of this repeating block unit changing, but it's much easier if you can show them a figure illustrating that point, like, you're going from one of those to two of those up to three of those, right? A figure really does help people interpret your work. And that's a problem I'll come back to a little bit later, that you guys are very familiar with your work because you spent all summer working on it. You forget that for most of your readers, it's going to be their first time looking at something like this, and they're trying to digest a lot more information than you are, and it's more challenging. So try and make it as easy as possible for them. More of the same on nice crystal structures and some more resources. So let's jump back. So now that we've talked how to make nice figures, posters. Right? So again, what are the qualities of a nice poster? And here, I'll refer you to the handout that went around the room. If you look at the second column. So the first one is capturing audience interest, which we might look at very end. Second column is on figures and fonts. Third one is on posters, right? So I used in the past, I had a big long list of things to do here, and that's breaking one of my key rules with presentations, which is don't put too much information on your slide. Instead, put on the slide just the key words that help you talk about the points you care about, right? So if you want the nitty-gritty points, they're listed there, right? But here's the main idea. When it comes to making a poster, first off, the first rule to remember is that you are the product, right? The research is not the product. Your poster is definitely not the product. You are the product. The poster is just a prop to sell you, right? At the end of the summer, when you guys will all present at the symposium, you are selling yourselves, right? You're learning how to present in public. You're hoping people will think that you're a good researcher, that you're thoughtful, that you've given this great deal of work, that you've accomplished good things. But very few people care about the research itself. They want to learn about you. So remember that the poster is just a prop for you to sell yourself because you're the product. The second one is that the audience has limited time and little or no interest in what you have to talk about, right? It's just the truth, right? Therefore, when I ask somebody, I'm going to put my brand new PhD student on the spot, Kai. Let me ask you, what do you work on, Kai?
Thermoelectrics and machine learning to help us decide what materials would be good for it.
That's pretty good. That's actually better than I was expecting, right? When you ask people what do you do during the summer, in the red class, ask what do you do in the summer?
Working with hydrogel sensors for detecting soil moisture levels.
Are you working with Jeff?
Yes.
That's fantastic. Anyways, normally people tell you, they answer the question like you ask. You ask them, what do you do? And they tell you what they do, right? I would ask Allie, she'd say, well, I'm making feminine hygiene products that are completely biodegradable, and she might describe how that's happening, right? Here's what I'm going to tell you to do. When people walk up, when they approach you at your poster, or in any context, if they ever ask you, if your grandma says, oh, you're going to college, what do you study? Right? Don't tell her what you study. Tell her two things. Why you study it, and why they should care about it. Right? Why they should care about it, and why you care about it. That's what you tell them. Right? Spend 80% of your time, 75%, spend most of your time telling those two things. Keep it brief, and then give them one sentence, one short sentence, no fancy words, tell them what you actually do, right? So Kai, tell your grandma why she should care about what you do, why you care about what you do, and then one sentence of what you do.
Oh man.
And seriously, like 4 sentences max. Keep it brief.
Why
I'm putting you on the spot.
care?
Yep.
I have no idea why she should care.
Why? Okay, anybody want to try this with their own research? Anybody want to give it a shot? A quick 30-second plug of what you do? Allie, let me pick on you because you're my group.
Okay. So am I talking about, am I answering the question about why I'm an MSc?
Somebody will say, oh, you're in college studying material science? What's that about? What do you study? Or you can do your research project.
Okay,
That's
I think the research project is going to be a little easier. So,
yeah.
Most feminine hygiene products are made with really harmful materials that take a lot of time to degrade in landfills, and it takes up a surprising amount of landfill space. I care about it because I am a woman and care about providing access to safe and effective feminine hygiene for people all over the world. What I'm really doing is aligning cotton fibers in such a way to maximize absorbency of biodegradable materials within them.
Bingo. That's perfect, right? So again, you're pulling the old politician trick. They ask you a question, you don't answer that question, you ignore that question, you answer the question you want to answer, which is really what they want to ask too. They just didn't ask you that. What they really want to know is, why should I care about this? Why am I standing in front of this research poster? Is this a waste of my time? You want to tell them by the end of that brief, needs to be 30 seconds brief, between that brief interaction, why they should stay at your poster and learn a little bit more about the what you did, right? So maybe everyone turn to your neighbor, and I want you to practice. Imagine your neighbor just asked you, oh, what do you work on? I want you to practice this 30-second pitch. Remember, why do you care about it? Why should they care about it? One sentence of what you actually do. No big words. super interested in people's research. That's awesome. How hard was that? Was that challenging? It's only challenging because you've never done it before. That actually gets way, way easier. Now that I've figured that trick out, it's way easier to talk about your research than to just dive into it and see people's eyes like glaze over because they don't know what you're talking about and they definitely don't care about it yet, right? So it takes just a little bit of practice. So I hope that you guys, before the poster symposium, when you guys go around the room, practice that. I want every one of you guys, as you're walking in the room, to learn about and care about what other people are working on, and that'll only happen as you learn to give these pitches. And again, 30 seconds. Now, 30 seconds, you might be thinking, well, normally at a poster presentation, people at your poster for more than 30 seconds. The whole idea behind this short pitch is that then they'll be interested, and they might have a follow-up question, right? If Ali told them, I'm working blah, blah, about biodegradable feminine hygiene, then they might say, like, I don't know, they might have a leading question, like, well, I thought they were biodegradable. It's like, no, they take like many, many years to biodegrade, right? Or sometimes they just don't, right? So you're setting it up for a follow-up question, right? One useful tool when you're doing this short pitch is to actually ask them a question, right? So for one of my research grants, we actually take bacteria, it eats coal, converts it to natural gas, right? And there's a lot of research involved in that. So when people ask me, I might say that. I say, oh, we take this methanogenic bacteria and we put it on crop and put it underground, right? And they don't care what I'm saying anymore because none of that made sense to them. So one thing that I find is useful is when they ask that question, to ask back, say, well, have you ever heard of this? Or did you know this? Like some interesting facts. So I would say on that one, I'd say, did you know that when we actually dig coal out of the ground, we leave like 99% of it underground? Right? There's a bunch of it's just too deep, we can't get it out. And they might say, I didn't know that. And say, so what would be great is instead of getting that out, which would be expensive and dangerous and that, what if instead we squirted some bacteria down there, right? It ate the coal, turned it into natural gas, and then we used the natural gas, which is a whole lot better than coal in the first place. So I work on bacteria that can do that, and means to get that bacteria underground, right? So you made it, all of a sudden they care about that, even though they knew nothing about maybe propent or maybe didn't know coal can be eaten by bacteria, right? You're explaining it in as simple terms as possible. Okay? Can I borrow your sheet real quick? There's a bunch of other points when you remember these. Let me read the last one first. The last point, all these points fall into these three categories. The third one is you have to engage with every single poster visitor, right? Don't just expect that you're going to stand there and they're going to look at it. This happens all the time. This is what happens. If this is my poster, someone walks up and they're like, and then it's like this awkward eye contact that's like, I don't know anything that I'm looking at here. And then they'll either just like mosey on over to the next poster, or they might ask some mercy question like, so you got some data? Like, I do. I have it there. Right? So you have to find a way to engage with them. Even people that aren't going to be interested or care at first about what you work on. So that's it. You're the product. The poster's a prop. Audience has limited time. They just don't care about what you're doing yet. And the last one is you have to find a way to engage with them. With that in mind, here's some actual useful tips. First off, nobody reads posters, right? Nobody reads a poster. Maybe if you're feeling really awkward at like, and you're waiting for somebody, you're in a hall and you're just milling around, you might pretend like you're reading a poster. Even then, I don't think you're really reading a poster, right? So don't prepare it like it's a manuscript where you read a manuscript, and that's how you digest the info. This is a prop. This is for you to point to something that's then easy for you to explain, and then you move on to the next thing, right? Because of that, I say to minimize text. Really minimize text. I'll show you some examples of like maybe even going too far on that. Try and cut out paragraphs. A few bullets are okay, they're better. Another point is to save the prime real estate on your poster, which is center and eye level, for the most important stuff. Even if that goes out of order chronologically. You know what I mean? Like maybe you had to like tell people why they should care about it. You had to make your material, you had to characterize your material. Finally, you got to the property that you care about, and that's the last thing you did. So you're tempted like, oh, I'll put that over here. It's the last thing I did, just above like acknowledgments. But this is not the most important part of the poster. Right there is the most important part of the poster. So even if it means putting it out of chronology, I suggest to put it, the most important stuff, where it belongs, right in front and center. I would say large font size. If you're using PowerPoint, most posters, that means size 28 or above. Anything less than size 28, banish it. Use 28 and above, right? And the way to know if it's going to work is you want this to be legible from 5 feet away, right? If people are a little bit, extroverted or introverted, you're staying away from your post a little bit, they can be 5 feet. So blow it up on your computer. It's got a little ruler bar in your PowerPoint. Make sure it's 1 inch, that the 1 inch is actually 1 inch. Then step away from your computer and see how easy it is to read. It should be very easy to read, right? There should be no squinting. Critically, don't leave out why you did your research or why the audience should care, even on the poster, right? So if for example, a great one for Allie, she's talking about the feminine hygiene thing, she could show a landfill like pie chart and show how 1% of all the stuff that goes in the landfill is feminine hygiene, right? And then you could even have like another blowout from that 1% that says, what does this look like? And you can say it's this many cubic feet, or the size of like 10 Titanics every month, whatever it is. It's some insane volume, but help them like have a figure there that helps them understand why you care about it, why they should care about it, right? So don't skip that on your poster either. And how much space should you dedicate to that? I'd say even a full third. If you do the standard format of like 3 columns, I would not hesitate from putting a full third, one full column to why they should care about it and why you are doing the actual research you're doing, right? So in the context of biodegradable, like we all want biodegradable products, right? Why is it that you're doing the small thing that you're doing, right? What is the cutting state of art, state of the art, current, cutting edge stuff that says, I think you should do what you're doing. Next, make references and acknowledgments small and brief. You should say thank you to the SPUR program or thank you to Office of Undergraduate Research. You should thank people who fund your research. Thanks to your mentor or the grad student that helped you. It's fine to put that, but it needs to be down here in the not important part of the poster and small and brief, right? There's the only time you're allowed to use font smaller than 28, right? Do your small font there. This is critical. Bring something to touch and show while you speak. I broke my own rule today. I usually have big posters that I can show you, right? When you stand in front of your poster, like, Allie could very easily have one of her homemade feminine hygiene products that she's making that's biodegradable, right? Right?
I'm not sure people are real okay with that, but yeah, sure.
They might, right? It'll get them interested. They'll be like, plus, here's what's great about it. While they're talking to you, you take it and you put it in their hands. You got a captive audience. That person's not leaving because they have your tampon, right? Or whatever you handed them, right? We had a group that, I'll show you, we made these goggles that can change color for snowboarding. They're just awesome. They actually had a prototype right there. They could turn the dial, make it change color. People thought it was the coolest thing ever, right? Have something that they can touch and hold that helps them understand what your research project is, right? That's a great tip to have there. Practice the short delivery. Ensure that the image resolution is large enough. This is my biggest pet peeve. When people make a poster, and then when it gets printed, it's just grainy and blurry because they like grabbed the first thing on Google Image without realizing that it was like 100 by 100 pixels, which is just not going to cut it, right? So make sure, and how do you know? Blow it up big on your computer and see if it's grainy, right? And then the last thing I put here is to think outside of the box. What do I mean by that? Consider doing your poster in a radically different way. I've seen sometimes this works, sometimes it's flopped. Usually it works when people do something different, right? Because it's memorable. That's what you want, because you want them to remember you and you're selling yourself, right? So maybe your project makes sense to have a circular design, right? If your research makes sense to do that. Something we did once that worked really well is we built a website, and we're talking about data mining. No one's heard of data mining, and no one cares about websites. That sounds like the most boring poster ever. But what we did, rather than just having a bunch of screenshots and trying to explain it, we actually cut a portion of our poster out and stuck an iPad to the back of it. In real time, we could show them just what was cool about this and how it actually worked. And that one that won a first place, right? So consider doing something interesting and unique with your poster. Keep it professional, but consider something interesting. So let's look at some examples, right? I've got blow-ups of these so we can make them bigger. These have all, in fact, everything I'm going to show you today is won either first, second, or third at the competition that it was shown in, right? So let's look at some of these in detail. So here's one. A student came to me with this one. This was his first draft. Oh, you can't see that. Let me duplicate my screen. Too many things open and they're all huge. So this is what he brought to me on his first draft. He was making a new lighting system for aquariums to prevent algae growth, but to help corals grow, right? This was his first draft, which really wasn't very bad. Oh, sorry. That was his second draft. His first draft had much more words, right? It still had nice figures. They were still interesting and compelling, but had these like huge blocks of text, which would be okay if this was like a research article and someone was reading this. But at a poster presentation, no one's reading your poster, right? They'll read a few snippets, but you want to keep it brief. So we changed it. We edited it down until it looked like this. Kept most of the figures. We changed them a little bit. But now this was maybe an example of going too far and cutting out text. And he really like mercilessly cut out everything. I think that every figure you show should have a significant a heading that describes it. He's kind of done that, but he's cut out quite a bit, right? So this is one example. Let's show you another one. From grad school, here's one that I did, right? Again, more text than I would like. This time they required us to have an abstract, and this was in the days before I realized that you could ignore instructions that are stupid. So I put an abstract up there. An abstract is a big block of text that you read, right? And again, now that I've learned that people don't read those, even if you're at a place where it says include an abstract, just don't, because it's stupid, right? But again, try and make your figures big, like cut down on text. This still has way more text than it should have had. Plus I put an equation, come on. No one's reading equations on posters, no one's reading posters, right? That's one there. Here's another one. This one won first place a couple years ago. Again, more text than I would have liked. Something he did that was great was he had this contraption that he built. First off, what is he working on? He's working on polycrystalline diamond. That's synthetic diamond, right? For cutting tools. Turns out diamonds we're putting them on gemstones for rings and stuff because we're foolish humans, right? Instead of using them for like cutting and grinding like we should because we're engineers, right? So because of that, we need to make fake diamonds. And his whole research project is like, okay, in the process of making fake diamonds, that's high temperature, high pressure. When you squeeze on it, you have to have a material that won't explode when you squeeze on it, right? So it's really not the most interesting subject you've ever heard about, and yet he made it interesting by saying, here's my challenge, right? Every time you squeeze on it and it fails, that cost my work $20,000. They gave me the job of saying, how do we develop new, better materials for squeezing that won't cost us $20,000 every time it breaks? Because you're going to break a lot of materials as you're making and testing something out. So he had to build his own contraption for squeezing, right? And have it tell him the information that he wanted to know by it, right? Because he had this device and he did a great job explaining it, this one took first place, right? It was a great poster in the end. It's still too much text, but pretty good. Then one more here. The snowboard goggle one went really well. They basically set the stage for like, why do you care about goggles that can change color? Well, when you're on the mountains, a cloud comes by or day, night, whatever, these things change all the time. I think you guys have seen this in the lab you work in.
Yeah.
Right? You'd like to have some variability in your goggle lens color. And right now, all you can do is just pop that thing out and let a new one go in, or have light-sensitive ones that change on their own that you can't control. How great would it be if you could tell it in real time which one of these you want, right? So they put together a cell, they show how they actually manufactured it, they show some of the synthesis that actually involved, which I think is fine. If you have some interesting synthesis pictures, I say go ahead and use them. They showed some of the key data, right? And then the proof in the pudding, like here's like the untransferred and the transferred state, right? So all of these are pretty nice. They all have more text than I would like. I would settle for somewhere in between. Let me show you just one more I think I've got. Two more. This was my student Layla. She just took third place with this one at a big conference, which is exciting. Again, more text than I would have liked, but the key data front and center. And then one more. And this one I'll talk a little bit about, because I think I'm going to follow this method and from here on out. This is one we discovered when I was a postdoc that I like. First off, it's white, it's simple, it's a 3-column format. We made our crystal structure, but we made it gigantic so we can run it up the wall. It looks kind of neat. Here's what I like about this though. It's telling a story as if it was like a slideshow. We just took each slide basically, shrunk it down, and gave one takeaway message. And if people really want to know more details, we had a little bit more in slightly smaller font, right? So what's the main takeaway of this one? We said, early metal oxides lie in a promising region of parameter space. I would have told people why that matters, some context for that a little bit ahead of time. But that's the takeaway message for this whole figure, right here. Early transition metals are reasonably abundant and low toxicity, right? Low risk. Right? So we have a figure that describes that. So that I think is a good model to follow when you make posters, is something like this. Have one complete sentence that describes the figure that you're going to show them, and if you need to have more data, go ahead and have it in a smaller section below. I think that's a good way to go. Okay, so having said that, we can now continue on our way to the next topic, which is, okay, we've described, at least in the world of my opinion, and you're welcome to follow anything else you like, in my opinion, what makes a nice figure, what makes a nice poster. So the next question is, how do you go about making these things, right? There's a tool that we're going to describe today called QtGrace. Why do we use QtGrace? Because it's free, right? It is open source. It's free. If you use Origin can also do this. Maybe your lab already has a license for that. If so, that's great. Most people I find don't, and they use Excel and they make just okay figures, and they can be a lot better. So here we're going to talk about how to use QtGrace. If you brought a laptop and you want to follow along, that was kind of the idea behind this. If not, I'm screen capturing this, and you'll have access to all these files. You can follow that link. You're going to click that link, the hyperlink. It'll take you to the box file where it's stored, right? Everyone has access to this? And if not, I can put it on a Dropbox, like open. But when you go there, you're going to see this. It says QtGrace examples. You click that. And there's another folder called QtGrace examples, because I zipped it, I think. And in here, you've got a bunch of different examples. First off, you've got QtGrace itself. That's the software. QtGrace Windows binary. So if you're using a Mac, go download the Mac one, right? But it's free. You can find it. Just Google QtGrace. It'll pull right up, right? What's great is that you don't have to do an install. It runs right out of that folder. So wherever you put this, throw it in your documents or wherever you want to put it, it'll run right out of there. So there's no installation required. And I've already tweaked this one to have some bonus features I'll show you in a moment, right? So that's the folder it works out of. Then you've got 1, 2, 3, 4 examples where we have data, and we can actually go through actually creating these plots. Some of them are multi-panel, right? The multi-panel is the option. Instead of doing an inset, we're doing multi-panel. Some of them are just complex, some are simple, right? So there's lots of examples there. We've got the Grace user file and the default file. These you shouldn't have to mess with because I've already installed them in your QtGrace box. But what these do is it adds custom color palettes or a certain sizing. It makes the plots square and stuff like that. So if you do install this somewhere else, you can go ahead and throw those in. And then the last thing we have is Web Plot Digitizer. This one up here at the top. Web Plot Digitizer is something we'll show you how to use in a moment. That's how you capture somebody else's data, maybe something that's already published or if a machine spat it out without the actual data, and you can turn that into data which you can then use. So let's go through this, right? When you go ahead and download this, you want to download this QtGrace binary. So I've got mine downloaded here. QtGrace examples. Here I've got the QtGrace Windows binary. In the bin folder, I don't know what the bin stands for, but bin is in there. You'll scroll down until you see QtGrace as an application. So this is an executable file. It says QtGrace on the logo. It looks like a figurine. Anybody trying to follow along? This is screen capped otherwise. You can double click this and it's going to pull up your QtGrace application, right? QtGrace is great because it's very, very customizable. There's pros and cons. In Excel, what's nice about Excel is that if you have like a legend or like a whatever, you can just grab it, you can click on it and drag it and move it wherever. Can't do that here. But that's actually the strength of this. In Excel, if you made 3 figures and you wanted to like stack them together to make them all line up, you had to like drag it to the exact same spot, and it's not going to look the exact same. What's nice about here is you can tell things exactly where to go, and it's not so hard to do. Other things that are nice is when you double click in this main palette, this is how you're going to edit the data that's appearing there. You've got lots of options for colors, right? So for here, we've gone ahead and we've loaded up really nice colors for you to use when you're presenting scientific publications. Feel free to use anything else you'd like, but this is a nice place to start, is this first column. Why? Because these have constant, they have what's called, I took this from a research article that was on this. The way that your eye interprets the difference in these colors has been like scientifically measured, and they're equal distance from each other. Does that make sense? Your eye sees them all equally differently, if that's the right way to put it, right? They're appealing to the eye because of that. They have high contrast from one another. If you make a data set that has 8 data sets, you can show them all nicely, right? So that should all be preloaded if you use the QtGrace that we downloaded for you. We put this custom palette in there. Okay, so how do you go about getting data into here? In Excel, you sort of have your columns, you hover over it, and you click the graph button, right? And up pops something, and you can tweak it a little bit. Here it's a little bit different. Here you have to prepare your data separately and send it into QtGrace. So we're going to do an example of that. If you look in any of these ones that we prepared for you, QtGrace, let's go to a simple one, like a linear example, right? Here we've got 2 data sets, and those are text files, right? Those are notebook files. If you click it, all it is, it's just comma-separated values, right? I had my grad student Jake put this together for me, right? So I don't know how long these are. It's some number of comma-separated values, right? So how do you generate these in the first place? You would go to Excel, or wherever else you get your data from. Random between... So let's say we want random numbers between 0 and 100, right? We're going to generate some data, generate some more data. So for whatever you're doing, maybe this is your data set, right? Right there. It's as simple as dragging it copying it, pulling up Notepad, right? Or whatever other text editor you want, pasting it, and then save. Now there's one catch. When you save it, it has to be data.dat. It can be whatever you want for its name, but the extension has to be a .dat extension. DAT. Okay? Once you do that, now it can bring that data in, right? So Jake's been nice and he's prepared that for us. We've got a bunch of data here. So what we're going to go ahead and do is in our QtGrace, we're going to bring that data in. Here's how you do that. You go to Data, Import, ASCII. ASCII is Notepad file. You can also bring it in from your Excel note sheet if you save it as a .csv. But there's some tricks there in telling it which column to take. I find it's really just easier to copy and paste your data here into a Notepad file, but do as you wish. From ASCII, now all you have to do is tell it where your data is at. So you're going to go to this little folder button here, and we're going to say, okay, ours is located in the QtGrace example, right? QtGrace example. This was in the linear example. Let's take linear data 1, right? Up pops our data sets. Nothing's been imported yet. If we look at our figure here, it is still empty. So now you're going to highlight the data you want to import, and you have to tell it what type of data it is, right? Lots of options. It could be just an XY data set, which is what we have. But if you want to plot data that's more complex, that has, say, error bars, errors on the Y, errors on the X, errors on both, you've got options, right? Or you could do a bar, right? If you want like a histogram, instead of a single data point, maybe you want like a histogram. You got bars right here. You could do it as that. We're going to do XY for these. So we're going to import and import. So both of our data sets got brought in real time. You can see them here now. Now, if you want to hover over this, let me move it over a little bit. Double click on that brings up now the ability to edit these data sets. Right now, they have no symbols applied, so our symbol properties, it says there's no symbol. If you wanted to apply symbols to these things, you could easily do it. If you wanted circles, for example, now you've got circles. If you want to take away the line, you could get rid of the line. If you wanted to make it a broken line, you could do that. It's all easy to do here, right? You can change the color to whatever you want, right? Probably not sangre since that's used for the other one, right? You can give it a name like data1, right? Which is now going to appear up here. We'll show you how to move that in a moment. And when you highlight the second data set, you could do the same thing over there. You could do squares, make it whatever color you want, right? Call it data set 2. Okay, so now you're like, that doesn't look better because now my legend's on top of my data. That's not great. So you need to move that. And like I said, in Excel, it's simply hovering over it and you would drag it. When I do that, nothing happens. What you have to do is you have to give it a coordinate location. It's actually not as hard as it sounds. This whole white area on which you can work goes from 0 to 1 in the X and from 0 to 1 in the Y. So the graph is currently plotted from about 20% of the way to 80% of the way, or 0.2 to 0.8, 0.2 to 0.8, right? So all we have to do is move it with that in mind, right? So we're going to come up here, we're going to go to Plot, Graph Appearance. We're going to click the Legend Box tab, and right now it's located at 0.55 and 0.75. So it's about half the way across in the X and about 3/4 of the way up in the Y. And that's not where we want it. We want it to be outside of our box. So let's just do one thing on our X. Let's make it go 0.81, right? Just a little bit outside of our plot boundaries. And you've got it right there, right? If it goes outside of the white, it won't show up as this exports it as an image. But it will show up if you export it from here as a vector image to Illustrator, which I'll show you how to do in a moment, which is usually what I do my final touch-ups in as an Illustrator, right? Now you don't have any captions, right, on your axes. Something you might want to add as captions for your axes. So you double-click your axes, or come up here to Plot and go to Axes, right? Axis properties. And for the x-axis, maybe you wanted to make it logarithmic or reciprocal. Reciprocal is really nice because a lot of times we care about things as 1 over temperature, right? So you can plot things as reciprocal space. It's a very nice tool. You can give it a label like x-axis label, right? When you click that, it'll go there. You can apply like Greek font, so for Greek letters and stuff, you can put them there. Maybe you want to plot like beta or something. You can do that by coming here and doing $, \, beta, right? That's one way to do it. And this will pop up, I hope. Yeah, you get a beta, right? That's one way to do it. This is called latex nomenclature for typing. I don't think it's easier than just leaving it blank. And when you send this over to Illustrator, pulling up the little symbol font and just typing the letter B, and you get beta. But do as you wish, right? This is one way to do it. You have to use the $, name of the Greek letter. Now, if you do capital, it changes it, I believe. Let's do like theta. I think that changes it. Oh, I messed it up. Anyways, you can type it in there. I rarely do it, as you can see. I usually leave it blank, and in Illustrator I type in the Greek letters, and it's just easier for me to do it that way. We can change things here. Maybe you don't like the values, they're easy to change. You can change where the tick marks are and the spacing between them. It's just much easier to control than Excel. Excel can do these things. I think it's easier here. And then the real reason why we use QtGrace is the ability to make those multi-panel plots. So let's go to an example of that. So we're going to close this one. You could have saved it if you wanted. We're not going to.
Quick question on the plot.
Yeah.
Can you switch X and Y axis?
Can you reverse them? That's a good question. I don't know if you can do that offhand. I don't know if you can reverse them.
I know you can do it, just change it in the notepad.
You definitely can change. You can just change your data and re-import it. I don't know if you can just switch it. That's a good question. Something that's nice, by the way, you can do alternative x-axis and y-axis. So, right, if you wanted, maybe this is some property, but that can be thought of, like, say this is like miles per hour, but you also want to plot kilometers per hour. You could have alternative axes, right? So that's what that alt x and alt y are about. So it's very, very flexible, powerful tool for plotting. Okay, we're not going to save this, and let's go to a multi-panel plot. So again, if you go to QtGrace and you go to the multi-graph example, you've got top data, middle data, and bottom data, right? What we're going to try and recreate is this figure. It's yelling us that the fonts aren't there. We won't worry about that for now, right? This is, I don't know if they're plotting here. This is from a paper we did a few years ago. But we wanted to show 3 different histograms so you can compare them. Again, you could do this in Excel. You could create 3 plots and sort of hover them over each other, and it's going to be just okay. Or you can make a very nice plot here. How do you go about it? Well, you have to declare 3 different graphs. So there's the overall plot space, and then you've got graphs. So this is going to be one graph with one data set. You can have 2, 3, or whatever, however many you want in there, right? But you're going to create 3 different graphs, and you're going to have to locate them relative to 0 to 1 and 0 to 1. How do you do that? It's easier than it sounds. So we're going to pull up a new Grace file. Okay, brand new Grace file. We're going to first off save it somewhere, so in the same folder that we're working out of, so that the data is right there. So we're going to find where we're working out of, which is in my downloads, QtGrace examples, multi-graph. Okay, you need to save it. I forgot to put .agr. The file type for Grace files is .agr, right? Just like Excel is .xlsx. For Grace, it's .agr, so you need to save it as that. That way, when you click on it, your system will know, open this with Grace instead of whatever else it might try and use, right? Now that we're here, let's first make our, instead of adding data first, let's split this one plot into 3 different plots, right? The 3 different graphs. How do we do that? Come up here to plot and go to plot appearance? No, graph appearance, sorry. Go to graph appearance, right? Right now, there's this G0, that means graph 0. They start counting from 0 instead of 1. Right? So graph 0 has 0 data sets on it. We haven't imported any data. So what we're going to do is we're going to take graph 0, we're going to duplicate it. Right here, we're going to duplicate this data, or this graph. Now we've got 2 graphs. You don't see anything different because they're right on top of each other, right? So they shouldn't look any different. And we're going to duplicate it one more time. Now we've got 3 graphs that we can import data onto. Now we need to change where they're located. This first one, let's say that's going to be our bottom data. We want it to go from here to here, right? So we said this started at 0.2 and it went up to 0.8. So if you split them into 3, you could go 0.2 to 0.4, 0.4 to 0.6, 0.6 to 0.8. So let's go ahead and do that in terms of y. We can leave x alone. Yeah, Shane?
Do you not want to use more of the white space in the graph? Is there a reason you're not
You can.
using more?
You can. I'm keeping it square, but if it made sense for a plot to be not square, for some reason, you could go ahead and do so.
So couldn't you just change it to 0.1, 0.1 to 0.9, 0.1 to 0.9, so square 1? Like, is there a reason that we leave margins along the side?
Oh, good. I see what you're saying. Let me pull it up and I'll show you. So I'm saying to go from 0.2 to 0.4 in y, right? And that creates this one there. This next one, we're going to go from 0.4 to 0.6, right? This next one, our last one, is going to go from 0.6 to 0.8. So your question is like, why are we using all the graph? Why don't we put like a small margin here?
No, why do we have the white margin at the edge of the graph?
Like over here and stuff?
Yeah, why aren't we using that? Just
You
for labeling and stuff?
You could. I think it's easy because going from 0.2 to 0.8 are nice whole numbers, so splitting it up easy. And it also leaves space down here for like labels. Okay. Labels here. Maybe you want to have an alternative label. But you certainly could. You could do whatever you'd like with it. Okay, if you wanted to give yourself a little bit more space, like maybe these aren't even the same axis. In this case, they are going to be the same axis. But if they were different and you wanted to leave a little space, you could, right? Or add a little bit of a gap to make it just look nicer. So let's go from like 0.61, and we'll have this one go up until 0.59 maybe. Have this go from 0.41, and you build in a little bit of a gap. And on this last one, we'll have it go to 0.39, right? So it's very, very adjustable. Now, one thing you're saying is like, hey, these numbers are overlapping on each other. If they're the same axis, what's great is we can just double click on it, and on tick labels, axis labels, and tick labels, we just reduce the character size to 0 and they go away, right? Do the same thing up here. Say we don't actually need tick labels on that because they're all the same common axis, so you can make them go away. It's very simple and easy to do here, right? So now you've got a plot that might make sense. Now, how do you add the 3 different data sets? It's not so bad. You come here. You're going to import data just like before, ASCII data. It already knows what folder we're in because we saved it in that folder. The only catch here is you have to send the right data to the right graph, right? We decided that graph 0 is going to be our bottom graph. So I take the bottom data, I tell it it's just XY data, and I send it in. Lots of errors. Something's wrong with my data. I must have saved that file wrong. Oh, I know why. Because I sent it in as XY, but it's a histogram. It's expecting bar. That's why it says something's very wrong, right? So change this to bar. Grab that bottom data. Still lots of errors. Did I do something wrong? I sent it to the wrong graph for one thing. Auto scale on I don't know. I'm going to blame my student Jake for preparing this data wrong. But it would be as simple as that, right? Take the data you want, send it to the graph you want, okay? I don't know what's happening here. Yeah, Shane?
Undergraduate or postdoc example, you had lines running through all 3.
Yeah. Okay.
Your graphs. How'd you generate that line?
It's possible to add. Maybe you want like a random text. Maybe you want like a little arrow that says like, hey, there's something happening here with your data. You want to label it. You can do all of that in Grace, but it is way easier to do that not in Grace, but to do it in Illustrator. So let's show you what I mean by that. I'm not going to save this. Let me go out to another one. Log linear. This is one that he put together. Right, so this is like a linear x-axis, a logarithmic y-axis. And maybe you wanted to label this or do something else to it, right? You're done with your data. First off, I think you could do some larger markers that are easier to see. You could tweak this a lot more. It needs like labels on your axes. But let's just do that in Illustrator for a moment, right? How do you do that? You come up over here to File. You're going to go to your Export Setup, right? Basically saying, all right, when I send this file, when it leaves QtGrace, what's the format that it's going to be in? Its default is going to be as a PNG file, right? An image. Meaning it's ready to go. You're going to send it to the journal as it is. You're going to copy and paste it, put it in your PowerPoint or whatever, right? So we don't want to do that this time. We want to send it to Illustrator, so we want an EPS file. You could do some other ones, but EPS is a good one. That's a vector image, right? It's going to take all this data, convert it to vector images, and allow you to open it. So let's do that. Let's apply, accept.
Why do you use vector instead of JPEG?
Anybody know the difference between vector and JPEG? Yeah.
I think vector, you can scale it as big or as small as you want, and the computer will use like mathematical representations between the different keys and I guess pixels, so that no matter how big you make them, it will never pixelate.
That's exactly right. So like if you export as like a JPEG, then you're actually assigning pixels to be certain colors. If you assign it as a vector image, you're saying there's an arrow that goes from here to here, it's got this ending on it, it's got this color, it's got this stroke, so it can recreate that and scale it very, very easily, right? So if you haven't learned how to use Illustrator, it's another great tool. You guys have it for free as students at the University of Utah, I think for 3 years or something, so use it. Like, don't use pirated software. Like, learn how to use this now because it's great and it's very, very powerful. So this one, I took his where it's linear. I grabbed the wrong one. Anyways, I opened the wrong file, but here's your data. Each one of these is a vector image, right? So I'm going to delete this all out. Oh, oops, that's the wrong one. Let me grab this. I'm going to get rid of that background for a minute, right? So you can zoom in on this. It's much easier to use a mouse with Illustrator. It's one of the software that's definitely worth using a mouse because you can like hold down Control and move it like that, or hold down, Shift and zoom up and down, or Alt and zoom in. So it's definitely a software that works to have a mouse. But if you grab some of this data, every data point, rather than just showing us a bunch of pixels, it's actually showing you where that should be. And it's really great because then you could modify it, right? Let's say you want to like grab this thing. You can go to Select. You can select everything that has the same appearance, right? every data point has the same appearance. It'll grab it. Something's wrong. Let's try this.
You have to ungroup.
Oh, I have to ungroup. It grouped it. From here, I should be able to grab this and select everything with the same appearance. You idea what's going on, Shane? Oh, there it goes. So now I've got all my data points. If I wanted to change their color, let's say they were just too small before, you could make them larger. You could change the stroke to be some different color, right? You can make it whatever you want. Change the thickness of that stroke to whatever makes sense, right? Which is much more powerful tool than just creating a raster image where you can't change the pixels afterwards, except if you're gonna go in Paint and try and like draw it on yourself. This is just a way better way to go. Again, if you wanted to change your text, maybe this was like your label and you wanted to change that to include Greek letters, you just type symbol, right? Symbol's going to pull up your Greek letters, so now you could have 400 and the unit is alpha, right? Or beta, or whatever you want, right? Very easy to do here. Okay, let's go back. Let me just do one more now. The last one I want to show you guys is how to, let's say you took data from somebody else, you want to use it. How do you go about adding somebody else's data, creating like a complex multi-panel plot? Let's go through that process. To do that, go to the web plot digitizer folder. Here it's got some data, right? So when I was trying to find data, I went to Ig Nobel. Anybody heard of Ig Nobel before? They take it, instead of the Nobel Prizes, it's the Ig Nobel, and they take completely ridiculous research and give them awards for doing ridiculous research. So the research article we're going to read is this one, The Case of Moulay Ismail, Fact or Fancy. And this is an actual research article where they tried to figure out, is it possible that this guy, this Sharifian emperor of Morocco, Moulay Ismail the Bloodthirsty in the Dark Ages, if he really could have had 888 children, right? So maybe you're following up on this and you've done some additional research, but you need to access some of the data that they have here. It's a strange paper. So here they have number of offspring versus harem size, right? You all, in addition to plotting against harem size, you want to plot it against other stuff, right? The strangest thing you'll see all day, right? So you need to get this data. So how do you go about getting that data? You could email the authors and say, I'm going to plot this data with some new findings. Can you send it to me? That's the most awkward, least likely to be successful way about going about this. They might do it. I don't know, they might. The better way to do it is just to grab the data yourself. So how do you do that? There's lots of software out there. A lot of free ones, there's some pay ones. The two good ones I've used in the past, one is Data Thief, which I don't suggest you use because Web Plot Digitizer is just so much easier nowadays, right? So all you have to do is you have to turn this into an image, JPEG, bitmap, ping, whatever, right? So you use the snipping tool. Sometimes you just double click them, it'll automatically do it. If not, come up here to edit in your PDF, take a snapshot. You're gonna grab this thing, right? It's now copied. Open up Paint.
Do you have to have the legend?
No, in this case, I don't need it. It would depend on what your data is. Maybe it's important for you to remember it. I don't know. But just paste it. And then you can save this as, again, a bitmap, ping, JPEG, whatever you want. You just need to save it, right? I've already done that for us. Then you come over here, and there's this handy-dandy link to Web Plot Digitizer. Anyway, my battery dies. That might be why we end this. Web Plot Digitizer. It's great because you don't have to pay for it, and you don't have to download anything. It works entirely out of your browser, right? So how it works, you just go up here, you say Launch App. And this is just their example data, right? But you could put in anything you want. You could say File, Upload Image. You could webcam capture. If you want to hold the article in front of it and catch it via your webcam, you can do that apparently. We already snipped it, so let's grab it. This is in our QtGrace. This is in the Web Plot Digitizer folder. And our images, where's our image? Did I not save it here? I saved it somewhere else. Kids versus data. But these are all like text files, data files. We need an image. Am I just blind? I think I didn't save it here. Oh, right here, kids. Right, some image file. So now it says, okay, what type of data is it? We're going to take XY data, right? So the first one's fine. And you have to give it points of reference, right? If you're going to be stealing this data off here, you have to give it points of reference. So it's really easy to do. It tells you, it says, pick an X1, an X2, a Y1, and a Y2, and then you're going to define what those points are, right? You say, got it, I'm ready. You click right here. if you notice, like I'm there, but it has a zoomed in picture up there. If you really want to make sure you get it right, you can zoom in. So you're gonna click. You're gonna put this one right there at 200. This one here at 0. This one up at 1250. That's a lot of kids. And you're gonna say we're done. And now all you have to do is tell it what those points are. They're both 0 to start with. One goes on the x-axis up to 200. The other one goes up to 1250. They are linear axes, not logarithmic axes. It's important you catch that if it's not, right? And you're done, right? Now if you hover over any given point right there, say that's the data point I wanted, it'll tell you what it is, and you could write it down on pen and paper, or even better, if you wanted to capture this data, you could go, just start clicking these things, right? Right? This is nice. It's even better if it could be automatic, and it can. So instead of that, it's going to clear this data. Well, if you wanted to see that data, you'd click View Data, and there's your 7 or 8 points that you manually selected. You can copy that. You can export it to Excel. You can do whatever you want with it very easily. But let's do this automatically even. When you do it automatically, go over here to automatic mode. First off, you have to tell it what's the data, the foreground. That's the data color. These are all black. All of our data in this one is black. So if I tell it go ahead and run, it's going to grab everything that's black on this whole plot and think it's a data point. So we don't want that, right? So you have to tell it to just look at some stuff. How do you do that? So let's clear the points. You come over here to the pen, and the pen lets you write on it, like sort of draw on this, right? So you can like draw like this, and everywhere that the pen goes, it's going to collect data from those regions if they're the appropriate color. That makes sense? So we're going to hit run, and now it's going to grab just data there. Now they've shown there's like a bunch of data on top of each other. I don't know what they're doing there. You have to interpret it. You could probably assume that those are like error bars, and you could grab the data accordingly. But this is pretty easy to do, and we're running low on juice. But when you're ready, you go ahead and export your data, and you're good to go, right? So once you've done that, you could then create a plot. Like let's say we want to plot, in addition to kids versus harem size, you wanted kids versus Legos on the floor at any given time, or kids versus arriving at church on time, right? These are things that I consider also worth plotting, right? And you can make a nice 3-panel plot. Again, you would grab these things, you would turn it into a notepad file, you'd send it to the program just like we've done before, right? Are there any questions I can ask about this? We've kind of gone through it once, so maybe I won't go through it again. Any questions?
If we don't have a Utah account to go to another university, is there any way we can use piece of software similar to Illustrator that's free? Do you know of any? There's
one called GIMP, so it's actually pretty good. They also have a version of Photoshop that's okay. GIMP is okay. That's the vector image one. If you don't want to, it's GIMP, right? No, GIMP is the Photoshop version. I'm sorry. And what's the Illustrator? Inkscape. Yeah, Inkscape is the freeware version. Inkscape and GIMP are the two not rip-off. They're free. They're not as good, but they're free versions of the Adobe products. But if you're me, or if I was you, I should say, just learn to use Illustrator and the Adobe products. They are incredibly powerful. They make beautiful graphs and figures. I think it's worthwhile. Okay, let me close this and get back to our presentation just to wrap up. Use Web Digitizer. You can use Data Thief if you prefer. I think Web Plot Digitizer is even better. I don't think we have time to go over how to prepare and present great slides, but we'll make these resources available. You can look through it. I think it's common sense stuff, like not having too much junk on your screen at a given time, having one message per slide, ways to simplify and pace your reader going through it. But let me save this before it dies and then answer any questions.